Hello, everyone. This lesson is lesson 2.3, and it is called Applications of Equations. And that's just another way of saying it's word problems. We're going to apply what we've learned into different kinds of word problems. To start in this first part of lesson 2.3, we are going to work on 4 different word problems, and I would say that you would want to have your calculator handy as we work on it. In addition, I will say that it might get to be a long video. Feel free to pause at any time if needed to take a break. All right, number 1. First word problem looks like this. A rectangle is twice as wide as it is high. If it has an area of 24.5 square inches, what are its dimensions? So we would think about what we know about finding the area of a rectangle. The area of a rectangle is length times width, right? So we know that, and we're going to look at this first statement up here that says a rectangle, is twice as wide as it is high. So the first thing we're going to say is, if we know its height, we know that the width is twice as big. So I am going to say that our variable, we'll call it x, is going to stand for the height. I also know that it is twice as wide as it is high. So the width, we will call that twice as wide, right? So 2 times x. We also know that the area of this rectangle is 24.5 square inches. And we know that the rectangle, the way to find the area of a rectangle is length times width, or height times width in this case. So we'll say h times w. So if I plug in what I know from right here and right here, that would be 24.5 is equal to the height, which is x, times the width, which is 2x. I multiply those two things together on the right. X times 2x is 2x squared, is equal to 24.5. Of course, we'll just do some algebra here. Divide both sides by 2, and I get x squared equals 12.25. I will square root both sides, right? So square root here, and I will get x equals, and if you're really thinking about it, and when you square root both sides, you would actually end up with plus or minus 3.5. Obviously, a negative doesn't make sense in this situation, so we will just look at the positive number. So the x would be 3.5. Looking back up here, height is what is my x. So the height is 3.5. And then if we think about the label, let's see, this was labeled in square inches right here. And so this would just be regular inches. So 3.5 inches for the height, and the width would be twice that, which would be 7 inches. And this would be my answers for the first question. That's just a simple knowing the area of a rectangle kind of formula. I think it's also fair to say that this book will assume that you know how to find the area of a triangle, which is 1/2 times base times height, and the area of a circle, which is pi r squared. All right, let's try number 2. Number 2. A high-risk stock pays dividends at a rate of 12% per year, and a savings account pays 6% interest per year. How much of a $9,000 investment should be put in the stock, and how much should be put in the savings to obtain a return of 8% per year on the total investment? All right, so if we start to think about this, word problems are sometimes hard because there's so many words, right? So if we think about this, the question says, how much of a $9,000 investment should be put in the stock? So how much in the stock, and how much should be put in savings? So how much in stock and how much in savings? That's what we're trying to find. So we're going to say that X stands for the money we're going to put in stock, which, if you remember, the stock up here is the stock earns 12% per year. And we will say that Y is going to be the money that we put in the savings. When we start a word problem, we generally want to figure out what is it we're trying to find, right? What are our variables going to stand for? If we remember up here, the savings gets 8%. All right. Now, the other 2 pieces of information, let's see, we know is that, oh, wait, did I say that right? No, let me back that up. This doesn't get 8%, this gets 6%. Savings account pays 6%, so this should be 6%. Okay, the other two pieces of information we know are right here. We know that we have $9,000. We're going to invest $9,000. Well, if we're going to put X amount in stock and Y amount in savings, and we know that we have $9,000, that means the total amount that I put in stock plus the total amount that I put in savings should equal 9,000. That's one equation. I have two variables, so I'm going to need two equations. Well, the other equation must be how much I want to invest, or how much I want to make in the end. So it's set up here that I wanted to get 8% per year total on my investment. So let me see, what does that mean I really want to make? I want to make 8% of $9,000. That's what I want to make. 8% of $9,000, if you multiply that out on your calculator, here it is, $720. $720. I want to make $720. Well, of course, I'd want to make more, but that's what this question is asking about, $720. Well, how am I going to make that? Well, however much I put in my stock, we'll say that's X, right? X is how much I'm going to put in my stock. I'm going to make 12% of that. So 12% of X is 0.12X plus however much I put in savings, which is Y. I'm going to make 6% interest on that. So that would be 6%, so 0.06 times Y. And the money that I want to make there is right here, $720. Now this is just a system of equations, and you've used systems of equations before. You used them in Algebra 2. I don't know if we did it in Algebra 3 at all, but you certainly have done systems of equations before. I'll just use substitution here to solve the system of equations. So here's my system. I will just change the Y to equal 9,000 minus X, just rearranging that. And then I'm going to plug that in right here. So I would have 0.12X plus 0.06 times 9,000 minus X equals 720. So I'm just using substitution right there. I will distribute the 0.06, so I have 0.12X plus this gets distributed to both things. 0.06 times 9,000 is 540, minus 0.06 times X is 0.06X equals 720. Combining like terms, I will combine the 0.12X minus 0.06X to get 0.06X. Since I'm running out of room, at the same time, I will assume I'm going to subtract 540 from each side. That would give me 180. And then I'll use my calculator. I'll divide both sides by 0.06, and I will get 3,000. All right, so what did I find? I found that I am going to put 3,000 in stock, because that's what my X stood for. So 3,000 in stock. And remember that I had 9,000 total dollars, which means there would be 6,000 to put in savings. And that is number 2. You will have problems like this in your LT check. These are very typical systems of equations kind of problems that we see in many places. All right, let's try. We have 2 left to try here, I think. No, we have, 2 left. All right, here we go for number 3. A car radiator contains 12 quarts of fluid, 20% of which is antifreeze. How much fluid should be drained and replaced with pure antifreeze so that the resulting mixture is 50% antifreeze? Okay, so if I read the question again, I kind of want to figure out what my variable should be. So if I read the question part, how much fluid should be drained and replaced? That right there is what my X is going to stand for. So the X is going to be the amount of fluid drained and replaced. That's what it's going to stand for. Okay, so now let's go back to the beginning here. A car radiator contains 12 quarts of fluid. So 12 quarts of fluid, 20% of which is antifreeze. So if I want to figure out how much antifreeze is in there, I would multiply 12 times 0.2 because that's 20%. So that's how much antifreeze is in my car. Then I'm going to drain some. So I'm going to drain X amount. I don't know how much I'm going to drain. I'm going to drain X amount, And I know that that amount also is 20% antifreeze. So if I multiply that by 0.2, that's how much I'm draining. So I started with 12, multiplied by 20% because that's antifreeze, subtracted 20% antifreeze of some amount. Then I'm going to put some back in. Now, however much I drain, I'm going to replace it with the same amount. So I'm going to add back the same amount, but this time it's going to be pure antifreeze. Well, pure antifreeze would be 100% antifreeze. It's not 20% antifreeze, it's 100%. Well, that would be like multiplying by 100%, which is 1.0. And it says the resulting mixture is 50% antifreeze. Well, I started with 12, I took out X, I put back in X. Well, how much I have now is still 12, right? It's back to 12, and I want this to be 50% antifreeze. Multiply that by 50%. Well, that's going to be 6, right? So 6 quarts of antifreeze. Well, let's just multiply these other things. 12 times 0.2 is 2.4 minus 0.2x plus x equals 0.6. I will combine these two, so 1 and a negative 0.2, that would give me 0.8x. At the same time, I will get rid of this. I will subtract 2.4 from each side. 6 minus 2.4 gives me 3.6. Divide both sides by 0.8. I get x equals 4.5. What did x stand for? X stood for the amount drained, and we're measuring it in quarts. So 4.5 quarts is my solution to this problem. All right. We have one problem left. It has 2 parts. This last problem is kind of a science problem. It is the free fall formula. It is the fact that we have gravity pulling things down on this earth. And the free fall formula is given to us by this equation. F of t is equal to negative 16t squared plus v sub 0 t plus h sub 0. And in your notes packet, it does tell you what these things stand for. So t is going to be time in seconds. The VO right here is the initial velocity, V0 I should say, V sub 0, that's the initial or the starting velocity. And h sub 0 is the initial or starting height. Okay, so question number 4 says this. A ball is dropped from a 500-foot high building. A, when is the ball 210 feet high? Okay, so if I look at my formula right here, this F of t right here, that's the total height. So it's height equals negative 16t squared plus v sub 0 t plus h sub 0. Okay, so I know that when is the ball 210 feet high, that's what I want my h to be. So 210 feet high is equal to, what is it I'm trying to find? When, which means the variable that I'm going to have to solve for is the t. So I have negative 16t squared plus, well, I must know v sub 0. V sub 0 is the initial velocity. If we think about what happens when we drop a ball, if we're holding the ball and then we drop it, our initial velocity is 0. It is not moving at all. So our initial velocity here is 0 times t plus h sub 0 is our initial height. Tells us right here our initial height is 500, so that would be 500. This, of course, is just 0, so that will cross out. So I have 210 is equal to negative 16t squared plus 500. We'll subtract 500 from each side. 210 minus 500 is negative 290 is equal to negative 16t squared. Divide both sides by negative 16. I'm going to go up here. And I get 18.125 is equal to t squared. I will square root both sides, and I will get t is equal to approximately, I should make that an approximate sign, plus or minus 4.26. Well, the negative part of my answer doesn't make sense here, so I'll just take the positive part of my answer. It will take 4.26, and if you remember, t was being measured in seconds. It will take 4.26 seconds to reach a height of 210 feet. Part B, when will the ball hit the ground? Well, I'm going to use this same formula right here. This is my height. When the ball hits the ground, if you think about it, the height will be 0. So I want to set that equal to 0. So 0, because that's the ground, is equal to negative 16t squared plus v sub 0t plus h sub 0. 0 is equal to negative 16t squared plus, again, the initial velocity would be 0. So that goes like that. Excuse me. Apologize for the announcement here. Plus h sub 0, which again would be the starting height, which would be 500. All right, I'll subtract 500 from each side, equals negative 16t squared. Divide both sides by negative 16. Negative 500 divided by negative 16 is 31.25 is equal to t squared. I'm running out of room. Square root both sides, and I get t is approximately equal to, I think, plus or minus 5.6. Negative number doesn't make sense, so 5.6 seconds is the answer for when it will hit the ground. And that is it. That is 4 kinds of word problems for you to try today in this lesson. In lesson 2.3 part 2, there will be 3 additional kinds of word problems to try. Good luck.